Hi everybody, this is Mr. Molikash. This is week 5 video to help you guys out with what's coming up in the homework and Alex. One of the first things you'll have to be doing this week is evaluating functions. So let's start off with something like, say, f of x equals x squared. And let's say you want to evaluate, say, f of 3. That's pretty easy, right? You just put 3 in the place of x, and then it tells you to square the x, so the answer would be 9. Let's say that we wanted to do something a little weirder, like, I don't know, say h minus 2. Okay, so the domain variable x is going to be replaced with something new, and that's h minus 2. So what used to be x that's squared is now going to be filled up with that new stuff called h minus 2. And you know, to square this out, you'd either have to do the FOIL method or the box method, however you're familiar with that. But the answer to that is h squared minus 4h plus 4. Okay. So there are other things you can put in the place of x, namely something bigger than x. This is going to be really important in a future lesson when we're dealing with something called the difference quotient. But for now, we'll just do like we did before. We'll take the x out and replace it with x plus h. Okay, so now what we're going to do is, again, fill that empty space up with x plus h. And again, just like before, you can do x plus h times itself all multiplied out. The answer to this would be x squared plus 2xh plus h squared. Okay, there are some functions that have a little issue with them regarding a domain, and the domain is the set of all x's that you can input into a function that give you a y value out. So with f of x equals x squared, you can put any number in for x and square it and get a number out, an output. But let's say that we have, you know, a different kind of function, say a square root function, and we'll call this one g of x, since we already used f of x for this function over here. So you know, what happens if I try to evaluate this function, say at -4? Okay, we'll do like we did before. We'll get rid of the x, and we'll replace it with -4. So if we do that, we have -4 plus 3, and then we get the square root of -1. And that is an imaginary number. We sometimes call that I when we're dealing with quadratic equations. But the number I wouldn't work for the domain of a function. The domain has to be real valued, or we have to have real numbers, not imaginary numbers. Okay, so we can say that g of 4 is undefined. Undefined. We're going to say that. Okay, in the imaginary world, in imaginary numbers, there is a number that makes the square root of x plus 3 work when you put -4 into it, but not real numbers. So when this happens, you can write undefined. Okay, there's one more function that has a problem with it besides the square root function, and that's what we call a rational function. So you know, let's say that we have, I'll use a new sheet of paper here. So let's say that we have a function h of x, and h of x is x plus 1 over x minus 1. So let's say that we wanted to find the domain of this function, and the way to find the domain is to take a look at the function, see what kind of function it is, and then try to see if there are numbers that you can't put in for x that make the function have a y value, or a well-defined y value. So the problem with this function is that there's a denominator, and you're not allowed to divide by 0. You can't divide by 0. There's no number that you can divide by 0 and get an actual answer out of it. You may not realize that, but you know, let's say that we could do 6 divided by 0. What number times 0 equals 6? There isn't one, right? So That's the reason why division by 0 is undefined. So what would make that problem happen over here? Well, if x were equal to 1, then I'd put 1 plus 1 in the top, that would be 2, and 1 minus 1 would be 0, and I'd be doing 2 divided by 0, which is still undefined, right? So the domain of the function that has a denominator, we need to make sure that the denominator can be a real number that's not 0. And so we're going to say that x minus 1 cannot equal 0. If you add 1 to both sides, you get x cannot equal 1. So what does this mean in the domain? For interval notation, this would be negative infinity to 1, union 1 to infinity. So this is the entire real number line just with 1 taken out of it. So this would be your answer to the domain. Okay, let's do another example. Let's say instead that we had k of x is equal to x minus 3 over x squared minus 1. Okay, so again, we're not allowed to divide by 0. So for the domain, we'd say that x squared minus 1 cannot equal 0, which if you add 1 to both sides means x squared cannot equal 1. And remember, when you take the square root in an equation, you should have plus or minus. Some of you missed that in previous homeworks. Okay, so how would we write the domain for this? We'd have to exclude both negative 1 and positive 1. And you'd union all three of these intervals together. Okay, we'll do one more example here with a rational function. Let's say we have j of x equals x minus 3 over x squared plus 1. I'll tell you that the domain for this function is all real numbers, and the reason for that is because again, we're talking about real numbers in our domain, and if you look at the denominator here, it's going to be the fact that this never does equal 0, no matter what value you put in for x. The only value that would make it 0, working this out real quickly, would be plus or minus I, right? And because I is an imaginary number, our domain is all real numbers, and this is the real easy way to say all real numbers. Okay, I got a couple more things to show you guys real quick. One of them has to do with upcoming homework problems that you'll have in week 5. I realize I say a whole lot. Sorry about that. Alright, so just make sure that you can see this in the video. Actually, I'm going to try to push this over a little bit. Okay, and it probably will be off the screen a little bit, but you get the idea here. So we'll do a couple of these. Well, actually, I'll do all of these, but the function that's in question here is this particular graph. So it's a function, but it's a graph of a function. We don't know what the equation of this thing is. It's probably piecewise, and it's got all different pieces to it. So what we're going to do is try to answer these questions just directly from the graph. Don't try to make up any equations or anything like that. Just use the values that are in the graph itself. So f of negative 2 is the y value right there at that point. And that point exists where it touches the x-axis there. So it's negative 2, 0. So the answer to this would be 0. So the ordered pair negative 2, 0 is on the graph of the function. So that means that when the input is negative 2, the output is 0. All right. F of 3 is the y value when x is 3. So the y value there would be 5, where this little corner point is. Okay. The next one says find all x for which f of x equals negative 1. So when f of x is the y value, we want to see where on this graph do the y values represent negative 1. So what I'm going to do is I'm going to draw a little line here, a really light line, and I want to say, okay, where does the function intersect that line? And it looks like 3 places. Here, here, and here. So when I put inputs negative 3, negative 1, and positive 1 into this function, the output is always negative 1. So here we have x equals negative 3, x equals negative 1, and x equals 1. Okay, similar situation here when f of x is negative 4. We can draw that line down here, and there's two inputs that make that happen. I'll go ahead and draw these in green. So there's one of them, and there's another one. And the x values that make this happen are 0 and negative 4. I'll put negative 4 first because it's on the left. All right, the x-intercepts are where the function crosses the x-axis. That happens at negative 2, so we'll use an ordered pair there, negative 2, 0. And then the other one is a little bit tricky. It's certainly between 1 and 2. You might think it's 1.5, but it's not. It's less than 1.5. And if you move up the ladder a little bit, so to speak, you can see that there's 2 points on the grid here. One's negative 1, and one's 2, 2. So to get from one point to the other on this line, you'd have to go up 3 and over 1. So it's actually moving a third of the way between 1 and 2. This would be 1/3 added to 1. This would be 2/3 added to 1. And this, of course, would be 3/3 added to 1. 3/3 being 1, and 1 plus 1 is 2. So this is 1 1/3, which the fraction for that is 4/3. Okay, the y-intercept, of course, is negative 4. That's when x is 0. And what's the domain? Okay, the domain is where the numbers that can possibly be input into this function give us a y value. And I've drawn circles and lines all over this thing, but there were no missing points on the graph. It was completely covered in, starting at negative 4 and then going forever to the right. So how do we say that in an interval? Well, if we can include negative 4 in the x values, we need to put a bracket. And then if there's nothing binding the domain to the right, it's unbounded, which means it just keeps on going right infinity. And infinity is not a number, so never put bracket at infinity. Okay, the range is all contained between negative 4 and positive 5. Negative 4 is indeed in the range, and 5 is also in the range. So we'll go from negative 4 to positive 5, and we'll include both endpoints. Okay, so that's an example problem about how to interpret a function graphically and how to get some information off of the graph to answer questions like this. Again, I can't stress this enough. Don't try to create equations or things like that to put numbers into. You're going to make that way too difficult for yourself. Okay, last item up for bids is dealing with functions in a scenario with geometry. So here's a problem 125. You'll have to do 126 this week, but the problem here is presenting a square with sides of length s, and they're all labeled s here, and the diagonal of length d, perimeter p, and area a. All right, so we all understand what perimeter means, right? The perimeter is the sum of all four sides. So if you do s plus s plus s plus s, then p as a function of s is 4s. Now you might say, like, why on earth did you put p with s in parentheses? Because it says to write p as a function of s. So remember, like with f of x, we will write f as a function of x. And what that means is that if you input the side into this formula, you're going to get the perimeter of the square. So if the side were 8, the perimeter would be 4 times 8, which is 32. If the side were 15, the perimeter would be 4 times 15, which is 60. So for any length s that we can input, this formula gives us this function rather, gives us the perimeter. All right, so the area as a function of s, well, what do we do to the side to get the area? Of course, you do length times width, or s times s, and that's s squared. So this is where things get a little challenging. I'll do some work over here, but to write area as a function of p, well, what we could do is we could take this equation over here, and I'll leave the s out of it for now, and solve it for s. And then we're going to do a little substitution. So divide both sides by 4. And what that means is that the side is the perimeter divided by 4. Well, what we can do here is replace the s in the previous formula. So the perimeter is involved. Instead of putting s here, we put p over 4 there. or that could be also capital P squared over 16. So either one of those is correct. Either you could say P squared over 16 or just P over 4 all squared. And it doesn't matter which way you write it. To me, it's fine. All right, so this is for problem 3. All right, to write P as a function of A, then what we have to do is like we did in the previous week and solve an equation for a specified variable. So, let's do this. We'll take P squared over 16 is the area, right? And the area is the perimeter squared divided by 16. So what we need to do is write P as a function of A, which means isolate P in the equation. So the first thing we'll do is multiply both sides by 16, and that gets rid of our 16s over here. And then the only thing to do is to take the square root of both sides. And I'm not going to do plus or minus square root, and the reason for that is because the perimeter of this square obviously can't be negative. It's a square, right? So we're just going to say that the perimeter is a function of area. When you put the area in, you just multiply it by 16 and do the square root. Okay, so that is the work for letter D. Sorry, letter D there. All right, so they get more challenging as you go on a little bit, but this is the way to deal with those, right? You want to know what is your input, what is your output, and what do you need to do to the input to get to the output. For example, with the diagonal, you could use the Pythagorean theorem, right? A squared plus B squared equals C squared. A and B being the legs of a right triangle, and then D being the hypotenuse here. So you just add these together because they're like terms, and then you square root both sides. And the square root of S squared is S, but the square root of 2 we don't know, and that's the diagonal. So the diagonal as a function of side is the side times the square root of 2. Okay. If you solve this for D, you're going to divide by the square root of 2. So I'm sorry, solve it for S, my fault. So this would be D divided by square root of 2. The perimeter is a function of diagonal. Well, since the diagonal is divided by the square root of 2 to make the side, we already know P is a function of S. So we can do P as a function of D here by taking this and putting it in for the side there. So we'll do 4 times the side length. Okay, and that's good enough. I mean, you could rationalize the denominator and make some other things happen, but this is fine. And then the area as a function of diagonal. Well, remember the area was the side squared, and the side is D over square root 2. So what we'd have to do is square that, and that would just make D squared over 2. Okay, so yeah, these will be maybe a little bit challenging. Do reach out to me in either the Ask Mr. Mullicash discussion board, or you can email me if you run into problems with this. I can maybe give you some pointers or intermediate steps. And there's a host of assignments due because of the hurricane. I did put off week 4 assignments until this week, until the 19th and 20th. So you should be able to turn those in, but we're going to try to do some catch up now so that the week 5 assignments are pushed a little bit back, but not an entire week. Okay, so we're going to try to scale it so that we can get back on track and finish everything in a timely manner. Okay, so this is week 5, and I hope you guys enjoyed the video. And don't forget, my email address is jsmolokach@johnstoncc.edu.